That means go.
Go ahead and go. Blue team did the voltage control system, and we did the steady state operating curve and step response in our presentation. And the members of blue team are myself, Andrew, there's Caleb, John, and Mitch. Contents will include the background and theory, the step response graphs, the step response modeling, the results and comparison, and the conclusion. Our system included the 5 horsepower 3-phase motor with coupling DC generator. You can see that picture on the left. And it also included the load lights and the motor power supply, and that picture is on the right. Here's a block diagram of our system, and it's on the left. It shows the input M of T going into the system. It shows our output C of T, and our output is measured in voltage, and our input is in percentages. On the right is our step response, and it shows a graph of the input percentages M of T versus the time, and then the output voltages versus time. Here is our steady state input for 75%. And it shows the input percentages and the voltage output versus time. And it becomes steady from around 40 seconds to 120 seconds. Here's our SSOC for the steady state operation, and it operates the best between 75% and 100%. And the customer wanted for us to find the voltages at 0 volts, 25 volts, 50 volts, and 95 volts. And the operating range for 0 volts is between 0 and 30% input. Operating range for 25 volts is between 70 and 73% input. The range for 50 volts is between 74 and 75% input. And the range for 95 volts is at 100% input. The theory, the transfer function G of S equals the Laplace of the output Y of S over the Laplace of the input X of S. And the first order plus dead time model is G of S equals the gain times E to the dead time times S divided by the time constant times S plus 1. Here's a step response graph from 85 to 75%. It's a step down, and the input is 85, follows along the, here's M of T, and it goes down to 75. And our output is the darker graph, and the output voltage for that is around 57 volts. And the step was between 10 seconds, or happened at 10 seconds. We use Fit2 for the modeling. Here's our modeling for the low end of the graph, which is 0 to 40%. And our dead time isn't as much for 0 to 40%. It's around 0.1 seconds. We'll come to the comparison later after we finish the models. And the output voltage was around 1.7 volts. Okay, the step was at 25 seconds. Step response model for the middle range was here's a step down of 65 and 50%. The K value here is much different than the one from the previous slide. It's much greater. And the output voltage for this step down is around 2 volts. And this step down happens at 25 seconds. And here's the upper range for 75 to 85% input. And this one fits much better than the middle range. And the output voltage here is around 71 volts. The steps at 10 seconds. And then here's a comparison of the dead time with a 95% confidence for the graphs on the left, and then for the model on the right. And the dead time decreases as you increase the input percentage. And the step response, they seem to be, whenever by the graph, the dead time looked to be all the same for each input percentages, but whenever we did the models, they definitely changed. Here's a comparison of the time constant graphs versus the models, and those show that our system is just random between 50 and 65%. The middle range is not very reliable. Here's a comparison between the gain, the graph, and the models. And as the input increased, so did the gain for the voltage system. There's a comparison for the tables. And then for conclusion, amount of dead time decreased as the input percentage increased for the modeling. The time constants were longer for the step ups and the step downs, and the gain increased as the input percentage increased. And I would recommend to the customer to use a higher input percentage to receive more reliable results. And for the customer, I wouldn't recommend using that middle range because we couldn't narrow in on 25 volts for that. That was found in the middle range from the SSOC. That's the end of the show. Any questions?